welcome to the weird wet world of western Washington and the singular Salish Sea. Today we are exploring the kelp forest just north of Point Wilson. This silent Sunday morning could be anywhere on the west coast, the view familiar to many Pacific paddlers. We will leave this normal perspective, and if not dive into, at least snorkel through the amazing world of this annual forest. Rather than plunge straight into the deep end, we will start in the shallows and see some of the myriad shorter kelp. The first to fly by is the feather boa kelp. This kelp grows a mere 50 feet long. I didn't stop to measure these, but I think all on screen are far shorter. This kelp favors warmer waters, warmer being relative. Continuing on, feather boa gives way to broader winged kelp. Among the brown algae, we find examples of red algae like red Optunia and Turkish towel. This thick biomass creates an ecosystem similar to dense shrubland. Were we to stop and search the undergrowth, we would find a plethora of crabs, ambush fish, and other critters waiting for food to drift past. Instead, the current propels us to deeper and striking ecosystems. Out of the murk looms the stalks of massive kelp. Looming over the shorter seaweed, like trees over shrubs, are bull kelp. These kelp create multi-level habitats. These specimens are practically petite compared to the vertigo-inducing heights they can reach. A mature specimen can reach 118 feet. 36 meters. Their blades alone can reach 13 feet. This is truly impressive when you consider the bull kelp rarely lives to be over a year old. To reach these staggering heights, the bull kelp is capable of growing 7 inches a day. Not nearly as fast as some species of bamboo, but still an impressive feat. Bull kelp has an interesting problem. The spores are released from the leaves. Unaided, the spores cannot reach the seabed in sufficient quantity to start the next generation. So to fire the spores to the bottom, the kelp drops spore patches called sorus. The spore patches are just the start of the mind-boggling life cycles of the bull kelp. Rather than try and explain the alternating generations, I will link various references in the description. I am already at the surface, so we will start by viewing the animals that live here. The bull kelp's long blades are the ideal habitat for schools of small fish like perch. The constantly moving surroundings offer plenty of places to hide. Despite the relative safety, fish must remain ever vigilant, for they are in easy reach of kingfishers and osprey. This leads most fish to be fast and flighty. In the upper area, the fish either pick clean the blades or rely on the current to bring in food in the form of microplankton. In addition to the smaller life form, the current also brings macroplankton, such as a variety of jellyfish. When we attach ourselves to some kelp to arrest our movement, we see a constant stream of cross jelly. We also see the more energetic Stormotoca artra, far easier to say hanging stomach jelly. On the far end of the scale, we find jellyfish that pose a non-lethal problem to people. Lion mane, sea nettles, and fried egg jellies all float through. Unlike the smaller microplankton feeders, the nemesis on these jellies can take out far larger prey. The battered fried egg jelly on screen was one of the largest I'd ever seen up close. Its milky white mantle was almost 3 feet across. The dense canopy is made possible by natural flotation. The kelp stalks end in bulbous gas-filled chambers. This chamber is full of carbon monoxide. It is unclear if this is due to a biological byproduct or evolved as an anti-predator defense. Either way, the air is quite hazardous to humans. Moving under the kelp blades, we find a sun-dabbled sea. While great kelp has blades branching off the entire length of its body, bull kelp has whip-like stalks. The thin, long stalks are home to few mammals, though we see a few limpets and kelp crabs. The thin stalks create a dramatic separation between the canopy and the seafloor. This open area offers the ideal hunting ground for harbor seal. Unfortunately, we did not see any this trip. For those who are curious, had we continued down current, we would have entered waters patrolled by some particularly large sea lions. While the fish and game warden informed us they are not hostile, I prefer to explore sea life that is smaller than I am. Because of its more exposed nature, few solitary fish linger in these waters. We found several schools of sand lances and what I think is smelt. As everyone from cormorants to chinook likes smelt, the kelp forest is safer than open bay. Smelt seem to be like french fries. You're not eating just one. The Midwar region offers the best chance at finding some of the larger denizens of the seabed. Here is a sedentary sculpin, to be more specific, a buffalo sculpin. This beautiful specimen gets his name from the horn-like ridges above his eyes. These sculpins can reach 14 inches long. Buffalo sculpin have several strategies to hide from predators. This is called crypsis. First, the sculpin remains stationary. Movement attracts attention. Holding still is not enough. The buffalo sculpin has several layers of visual camouflage. The blotchy pattern breaks up the fish's shape. The technical term for this is disruptive coloration. The green and brown camouflage is impressive enough, but the fish can fine-tune its color scheme. Their skin is capable of a limited degree of color changing. This impressive camouflage is not perfect. As this tailless individual attests, there is always a bigger fish, even if it might have been a seal. On the opposite end of decoration, we find the majestic female kelp greenling. These flamboyant fish are incredibly fast. The far more somber male kelp greenling is the one who would guard any eggs. I had the pleasure of witnessing 2 female greenlings during this trip. Down near the bottom, we can see that each massive kelp is tied to a substantial boulder. This gives me new perspective when I look at the kelp forest from above. Kelp uses the descriptively named holdfast to secure them against the constant drag of ocean currents. Numerous little creatures live on and in these sturdy structures. The holdfast also exposes kelp to the dangers of benthic predation. Ravenous sea urchins will eat any algae they can find. Starfish wasting disease has upended the marine food web. There is now little to limit sea urchin populations. Like a herd of elk without any wolves, the sea urchin will eat any new growth, decimating the forest. The kelp in this area face the constant current from all the water flowing into Admiralty Inlet. Any kelp unfortunate enough to attach to too small of an anchor will be dragged. As any unfortunate captain can tell you, this does not lead to an enjoyable maritime experience. I have to wonder just how far some of these boulders have slid. Down on some of the smaller algae, we find a striking marine predator. These amazing little critters are confusing to talk about. They look like an enemy and fill a similar ecological niche. However, these are striped stalked medusa. They're cnidarians. Think jellyfish. Now when I say jellyfish, you probably thought of something like this. I can explain, but everything I'm about to say is a generalization. Jellyfish vary wildly from species to species. The jellyfish on screen are the medusa stage of their life cycle. For these specimens, the medusa stage is a pelagic existence. The animal swims by contracting its bell-shaped body. The medusa uses trailing tentacles armed with nematocysts to kill their prey. These medusa reproduce by releasing gametes into the open water. The fertilized egg develops into a larva, which migrates to the ocean floor. This larva grows into a polyp. The polyps on screen are moon jellies in the Sydney BC Aquarium. Over time, each polyp will grow several buds. Each bud will pop off to become a medusa. Okay, are you still with me? Here comes the curveball. Stalked medusa skip the swimming medusa phase. These polyps you see are in the final sexual phase. These polyps will release gametes into the current. The larva will swim to the bottom to grow into new polyps. Despite their soft bodies, the stalked medusa are remarkably durable. These ones were in the turbulent infralittoral zone. Stalked medusa are armed with the same biological weapons swimming medusa wield. Each of its 8 stalks are armed with nematocysts, stinging cells. This little guy is not a threat to a thick-skinned human, but is more than capable of killing amphipods and copepods. I don't think I can possibly communicate how excited I was to see these. I would like to shout out Eric, the other snorkeler making waves. He is the reason you get to see the sculpin. While I was swimming, I got to hear a choral school practice. Unfortunately, down the forest they sang algae. They needed some kelp getting to high sea.